Okay. Welcome, everybody. Thank you for coming to this session on creating your minimum viable product in under 1 hour. It's the end of build. That's amazing. I'm sure everybody's exhausted. I know I am. So, heads up. This session's never been done before. You are all my alpha testers. And, you know, the gods of fate had a funny way of deciding to put a session where I was going to do a lot of live coding at the very end of build after I'd been staffing a booth for several days. So we're going to see how this goes. But I'm excited to show you some things and kind of what I conceive of when I talk about minimum viable products. So let me just start by saying, who am I? Why am I even talking about this? Why does this matter? Why should you be listening to me right now? So I'm actually a product marketing manager for Azure Integration Services, which includes API management, Logic Apps, Service Bus, and Event Grid. But I'm also a writer. I did a stint for about 3 or 4 years as a developer, primarily with Node.js and React, but I've also worked across the entire stack. And I've also been an entrepreneur. I've had a couple of different companies. I've launched a couple of little products to not great success, but some of them were okay. And my businesses were definitely lifestyle businesses. I've never really taken anything fully to the VC scale. With that said, I've also worked at startups, and so I have a lot of experience iterating very quickly and trying to get products out to market as fast as possible. Also, I used to attend hackathons, and I did that kind of competitively for a while, so I have a couple of good stories I'm going to tell about that. So, one thing I'm going to mention here, which this slide seems a little out of place, but I didn't really want to get rid of it because it's going to come back. This is kind of the anatomy of a rapid development team, and I'm just going to go over these things, and I want you just to park them in the back of your head. By the way, we are going to get to mostly the app development side of this, but I do want to contextualize you guys first a bit. So generally when attending hackathons or doing kind of rapid development, the 3 principles that I've always kind of adhered to are you should have one person focus on one thing. So if that's one back-end developer doing a back-end thing, one front-end developer, or if you have a larger team than that, it could be multiple people spread out across different areas, but generally break them apart by division. Each person within those divisions should own a subset of the problem, and each person does not have dependencies on the other person. This is going to become important later, I promise. So let's go ahead and just skip past this one, and we'll come back to it. Okay, so creating a minimum viable product in under 1 hour. But what is a minimum viable product? It's kind of a vague term. We all have different concepts of what that actually is. So I'm going to give you my definition, and you can agree or disagree. But the way I look at it is a minimum viable product is a product that solves a core problem for a potential customer. And this is kind of really important. You'll notice I highlighted the word problem here because it's really impossible to create an MVP without first identifying the problem. And this approach is how I have seen success at hackathons and in kind of my smaller business ventures. So I'm going to quickly breeze over this, but starting with a minimum viable product. So what is the problem? Who am I solving this problem for? And what is the actual minimum viable product that solves this? And this is a problem-first approach to creating things and kind of innovating. One thing I want to mention is that it's a little difficult to come up with an idea in a vacuum. There's a lot of ideas you could choose. So I've kind of selected some industries here that I've attended hackathons at or I've created solutions for that are in desperate need of innovation and would definitely, they're prime targets for looking for problem areas. There's one thing that I left out here, and I left this out intentionally. I'll show you in a second. But you can kind of tell that through these industries, you have kind of some of these. These aren't all the industries, by the way, but things like manufacturing, retail, finance, logistics. They have these massive problems that you can create small solutions for, and then they can actually take to scale. So if manufacturing, for instance, connected machines, the connected factory, that gets talked about a lot. Retail, things like supply chain, shipping and logistics, tracking life cycle of a good, really thorny problems for retail. Finance, I don't know that much about. I know they have problems. And logistics, once again, another really difficult problem. They have a bunch of stuff that needs to get kind of figured out around logistics. However, with these particular scenarios, they do have kind of a commonality. A lot of these scenarios are based around connectivity. They're based around integration, or they're based around the movement of data from one place to another. And when I've been attending hackathons that are sponsored by giant corporations like Maersk, most of the problems revolve around this kind of this subset. So with that said, the one industry that I have not put here yet is healthcare. Because healthcare is in desperate need of innovation and ideas and ways to kind of modernize what they're doing. It seems that the healthcare industry is putting on a lot of hackathons and looking for these kind of innovation efforts. So it's just a great place to kind of ideate around. And I put things like wearables, embedded devices for health monitoring. I actually worked for a company who worked with a healthcare provider that had connected pacemakers. And which is kind of a frightening idea when you start to kind of think about that at large. You gotta wonder about how hardened that security is on a pacemaker. But yeah, so that's just a great place to kind of look at. So I'm gonna kind of breeze past that. So let's go into actual real-world examples of what this looks like. So we're gonna take a problem-first approach, as I said before. So I have 2 examples here. The first one being a project that I created called FLO Force One. FLO Force One was actually for a GE hackathon based around industrial Internet of Things solutions. And we took my team, there was 2 of us. One of them was not a developer, and I was the developer on the team. We took home the grand prize, competing against 60 other teams comprised of 6 to 8 people. That was $25,000. So it was a pretty nice net sum to win from that hackathon. And these other teams, they put together these compelling demos, but they can never actually get to a real product. And that's always the issue with these hackathons, right? And so we did all of this in kind of 20 hours. So as far as our solution, as far as the problem we identified went, that blurb up there I think does a good job of kind of explaining it, but it was really about fleet management and getting to an asset somewhere in the world, wherever it may be. The example that I like to use a lot is a wind turbine at a wind farm. Let's say there's a wind turbine at a wind farm, and its temperature, it has a temperature sensor on it, and that sensor exceeds some sort of threshold. And it ends up that the wind turbine is on fire. Well, you're going to need to send some sort of service fleet out there to kind of deal with that as a problem. So we created a full end-to-end solution that would actually go and look for the nearest service fleet out there, and it would send it to the wind turbine. And then they could scan, this seems like a bit of a poor mitigation scenario, but they could scan a barcode and take it off the grid, and then I guess problem solved. Yeah, so perhaps we need to take this one step further and kind of figure out how we could integrate better with more emergency scenarios. But it was a really great solution, and it addressed a really critical pain point in these kinds of industrial Internet of Things scenarios. So the next question is, who am I solving this problem for? And this is really key when you're creating an app at a hackathon, or trying to find your minimum viable audience, which kind of pairs with minimum viable products. And in this case, it was for energy, manufacturing, and infrastructure enterprises. And so the approach we took is kind of, as I said before, it was an entirely automated solution that ingested IoT data. And we used this because it was a GE hackathon. We used Predict services. You could create a very similar, actually probably equivalent scenario using Azure IoT's various services and whatnot, but we used Predict's time series, Predict's asset, and Predict's dynamic mapping. Those were all the backend services. Additionally, we used Google Distance Matrix. And on the front end, it was just a little bit of HTML and CSS. And so this picture up here is actually not representative of the final product. This is representative of a workflow orchestrator that we used in the past, and that shows about four workflows. Workflow orchestration, for those who aren't familiar, would be something like Logic Apps. This is actually a visual designer. But that's 12 workflows, but all in all, I think at the end of the day, we had something like 30 workflows working in concert with each other just to achieve this one thing, which was pretty tricky. Let's see, that one was created, yeah, so that one was under, yeah, that one was just trying to remember my timeline here. Yeah, that one was under 20 hours, and that one was pretty rough. But I remember my train of thought here. The reason why we chose an automated solution, and the reason how this ties back to the, who is your audience, is because this was not an interactive application. This was something that just needed to be set, and then it needed to be left alone, and then it had to be totally available. And so that's why we went with this kind of automated approach. The next one I'm going to kind of identify here is an app that we created at a TechCrunch hackathon in London. We flew over there. We're based out of Seattle, and we flew over to London and proceeded to participate in a 30-hour hackathon where we didn't sleep or anything like that, but we created a consumer-based app called Wandered Space. And so the problem that we ended up discovering was that when we got to London, we had been booked at an Airbnb in a neighborhood that was way far out there, and we didn't know any of our surroundings. We'd never been to London before, but we wanted to kind of discover what was within walking distance of us. So we said, okay, how do we find those things? So we decided to create Wandered Space, which is an app that essentially lets you take a walk, and it feeds you these kind of critical steps along the way of things you would otherwise miss, that you might wander past, hence the kind of name Wandered Space. So who am I solving the problem for? First-time visitors to a new place, locals who are looking for the unknown spots, definitely a consumer-facing application. So this is actually an example, minus the little text there in the middle, but this is an example of the UI that we created. This was it used Esri ArcGIS as well as React and Redux for the front end. We used Factual API for the back end, and we used another workflow orchestrator, a visual workflow orchestrator, to create all of our back end services that integrated with the Factual API. And for those of you who aren't familiar with Factual as a service, it's a location data provider. It's pretty cool. No affiliation. So that one was interesting because we thought that we didn't really get it out. We didn't get to the state that we wanted to be in, but we were pretty happy with the way that the UI looked, but not in terms of functionality. But we did end up being runner-up at that TechCrunch hackathon, and this piece was featured on TechCrunch as a featured article. And that generated a lot of traffic for the business that we were working for at the time. So it was a pretty cool piece of rapid development. I'm not going to talk about, this one, but it'll be in the slide if you want it later. This is one that I articulated specifically about healthcare. It's an interesting problem, but you guys can check that out later. So we've kind of addressed the first bullet there as well as the sub-bullets, which is what is the problem, who am I solving this problem for, and then what is the minimum viable product for this problem. So we're going to go into the kind of solution area now, talk about the technology side of it. What technology should we solve the problem with, and why should we go with this approach over a different approach? Okay, we have our idea. How do we bring it to life? So this is kind of an idea that I've kind of consolidated down on after doing a lot of these hackathons and whatnot, that I've kind of started calling composition-driven development, because we all need another acronym in our lives. But it's really a style of development that focuses on sourcing out as many of the pieces as you can that aren't necessary to the core value of your app, and focusing on composition of systems. So basically grabbing individual services and composing them in such a way that the sum becomes greater than the whole, or than you know what I mean. The individual parts are greater than the sum is greater than the individual parts. There we go. I knew I'd get there eventually. This idea of composition over inheritance is nothing new. I mean, like back in 1994, the Gang of Four wrote the design patterns book, and composition over inheritance was key to that. And this idea of composition has been spread out through programming languages and development for a very, very long time, 25 years now at this point. So I see this as the kind of the logical evolution as more and more services, like, for instance, like PaaS services that Azure provides, and SaaS services that all of these other cloud services provide. As we move these kinds of details increasingly into the cloud, it's more about composing these systems and turning them into apps. Yeah, and what's interesting is that this idea of composition over inheritance is really this modular approach, and you're seeing it also in languages like JavaScript, who really preference modular development over kind of an object-oriented approach. So what does the toolkit look like for composition-driven development? Well, here's some of the things that you can use. The way I kind of look at it is that there's these 4 key things. Well, 3 plus 1, because Cosmos DB just got added recently to this. API management, which provides the front door to your application, as well as helping you wrangle things like functions, which would be the next step here, which is the single-purpose business logic for your applications. Logic Apps, which provides orchestration between something like functions. You could feasibly use something else. And then Cosmos DB, because Cosmos DB is just really cool and you should use it. But in actuality, it happens to be very, it's a very capable database for doing kind of rapid iteration because you're not beholden to one specific model. And so you can really change that out fast and do that in a meaningful way. So the benefits of composition-driven development. So remember anatomy of a good rapid development team that I asked you guys to hold on to at the beginning of this? One back-end developer, one front-end developer, each person showing a subset of the problem, et cetera, et cetera. Well, it ends up that this corresponds really well to developing. So not just the team benefits correspond really well to the development benefits. So if we kind of change this a little bit, we can take number one and turn it into in composition development, a single service should perform a single function. A service should own a specific subset of the larger problem, and there should be no dependencies on other services. And all in all, we get to this thing that's more of a microservices architecture, or at least some of the benefits of microservices architecture, which is kind of one of these models that tends to be prevailing right now. And so I kind of look at composition-driven development as more being like a mindset around when you get started developing. And then microservices architecture is kind of the end result of having kind of started down this methodology. Okay, so it is time to build the application. Not really. I'm first time going to talk about this. So I'm cheating a little bit here because in my abstract I talk about building something from scratch. I'll let you know that over the past 3 days I have built something from scratch. I'm going to try to build it from scratch in front of you from memory based on this kind of scenario that I'm going to line out for you guys. But it's not going to be perfectly from scratch. So the idea that I kind of saw was let's go ahead and create something like I'm calling it MicroStarter, which is a crowdfunding platform for less expensive things. An example of that might be that let's say that everybody wants to go in on a keg or something together, something that is not super expensive, and this service would help facilitate that process. And so I'm going to hopefully create the service in front of you, or at least create slices of the service in front of you so you can understand how all of these how you can use this toolkit to actually create an app in a reasonable amount of time. At this point now, we're going to try to create the app not in under 1 hour, but in under 42 minutes. So we'll see how far we get along with this process. There are 3 requirements that I kind of set. The third requirement, that's not going to happen. Technical difficulties, and React, as far as the technology is going to get used, I'm not going to deal with that. I'm just going to deal with the back end in this case, but you can plug it into whatever front end that is applicable to you. Okay, so let me go ahead and flip over here. I want to say that this was the right one. Let's find out. Let's try that one. Oh, that one looks better. Nope, it was that one. Okay, go. So what we're going to do here is a couple of things. First, we are going to create our logic app. So I've done a few tests here, but we're going to do this from scratch. So I'm just going to kind of go down. If you guys saw that architecture, oh, you know what? Actually, hold on a second. I'm sorry. Let me step back because this is worth going over. This is actually really worth seeing. So the architecture on the right, which I should have kind of walked you guys down, the way I look at it is there's kind of these 2 verticals there's interaction that's going to happen via text messages, and so you guys will actually be able to text a phone number I'm going to provide, and you'll see your data auto-populate over in Cosmos DB. Then there's the campaigns, which would be the thing that you're actually trying to fundraise for. API management kind of sits in the middle between those 2 things. That's kind of the management plane, as well as providing the facade. And then we have 2 logic apps, the second of which we can make, but it's not the biggest thing. And the first of which is going to be kind of the beefy logic app that handles a lot of the orchestration and the connecting to the individual services. Okay, now let's switch over to the actual, there we go. Okay, let's switch over to that. Okie dokie. So show of hands, how many of you are familiar, or how many of you use logic apps? Okay, that's a good amount. How many of you are familiar with Logic Apps? I don't know how many people double dip there, because if you use Logic Apps, you're probably familiar with it. But okay, so that seems good. There's a lot of you who aren't super familiar with Logic Apps then as a tool, but there's a good amount of you that are. So I mentioned this before, but just really briefly, Logic Apps is a visual drag and drop workflow designer that provides, like, I think 250 plus connectors to various cloud services, including a large majority of Azure services that you can connect to and do some fun stuff. So let's go ahead. So I'm going to walk through this, and we're going to kind of start the process of building this service out. This is me hyping myself up to see, in case something goes wrong, I have that confidence to fall back on to. Okay, so let's go ahead and call this, microstarter build 2019. Go ahead and use an existing resource group. I'm going to assume that people understand some of these details. I'm not going to go over all of them, but if anybody has any questions afterwards, by all means, please go ahead and ask them to me. So let's go ahead and create this. So I'm going to use API management last. I'm going to use it as the facade over all of these things that I'm doing, and in the meantime, I'm just going to use Logic Apps as the main layer, the main interaction layer. So I'll show you what that looks like. Okay, so let's go back over here, Logic App Designer. Okay, so this is Logic Apps, in case you're not familiar with it. It's just this dashboard that has nothing going on in it. No, that's not true. Let's go into here. So we're going to create a no, we're not going to create a blank Logic App. We are going to go back. Well, that's fine. We can create a blank Logic App. Oh, no, there we go. So we're going to create a Logic App that is triggered when an HTTP request is received. And so what this means is that when the Logic App is going to provide a URL that will be able to be hit by some sort of service that will then trigger the body of the Logic App. So for the sake of, I'm going to do this. So you provide some schema. It doesn't matter in this case because we're not going to be worrying about that right at this exact moment. We're just going to kind of go down and do some of the scaffolding of this. So the way that I kind of envisioned this step working is kind of as follows. With this particular Logic App, it's going to use Twilio. How many of you are familiar with Twilio? All of you, or most of you. Okay, that's good. So it's going to use Twilio Twilio is going to. We're going to provide a URL to Twilio, and a Twilio webhook is going to trigger this Logic App. We're going to capture the response from that Twilio webhook, and we're going to parse out data from that body of that request, and then do some things with it. And you'll see how that all functions inside the Logic App. So we'll do that kind of first step here. So we have the HTTP request. What I'm actually going to do is I'm going to grab the Twilio bit here, and I'm going just to start kind of scaffolding this out before we actually get into the nuts and bolts of how this all works. So get message, yep, unique SID of the message. Just do that for now. Message, let's see. So then we have the HTTP request, we have the message. We want to check to see, oh yeah, I remember now. We're going to use Cosmos DB now to actually create a user inside the database. So I'm going to go ahead and stop here at these three steps and just show you guys what this looks like in practice. So let's go ahead and grab this URL. I'm going to go over here. When the message comes in, just by the way, so I have Twilio already open. I'm just providing the URL into the webhook spot that is going to get triggered when somebody text messages this particular phone number. So we're going to do that. We're going to hit save. Okay, so in an ideal world, what will have happened is that Twilio will now trigger this webhook. And so let's go back over to Logic Apps. I'm actually going to nuke this for a second. I'm going to hit save. And so what I'm going to do, just to see, just for a gut check here, I'm going to send a text message to this thing I already have open. We'll see if it comes through. It's always a good sign. Let's see. Yeah, no, it came through, so that's good. Let's go open this a little bit larger. So you can see that the Logic App was actually triggered via the Twilio webhook, and now we have this body to deal with and all that good stuff. The value that we actually care about in this case is going to be the message ID, which is somewhere around here. There it is, the message SID. So we're going to extract this value from that request and actually provide it to the pre-built Twilio connector. So let's go back over here. Let's hit edit. HTTP request is received. That comes out of it. Oh, actually, I'm sorry. One thing that is going to be very, very helpful is we have to provide a schema to that HTTP request, and the reason why is so that you can use all of that data later on in the Logic app. So we'll grab that. We just grab that, go back over to here. So I'm just applying the sample payload that came from Twilio into here. It's going to auto-generate a schema for me. And you can see this is what the schema kind of looks like. It's just basically saying, oh, what are the types, all that kind of good stuff, so you know what's going on. Now we can go over here to get message. Let's see, back down over here, go into add action. And what we're going to do is we are going to parse that data that we got back from the HTTP request. Make sure that that's what I want to do here. Yeah, hold on a second. Did I actually create the schema as I wanted it to? Well, we're going to see what happens. Oh, here we go. Yeah. Okay, perfect. So we're not a compose card, a parse card. Let's go back down here. So if you're not familiar with the data operations in Logic Apps, these are just a way to essentially operate on sets of data, as the name would imply. The HTTP request is received. We're going to take the body and we're going to parse that out. And this is also, we can go down here, use sample payload, generate that. Okay. Definitely contains invalid parameters. Oh, whoops, yeah. Let's go ahead and just kill this for a second while we save this. And kill the compose card, because we have a lot of garbage in here. Save, there we go. Okay, so I'm a big fan of kind of an iterative approach, especially when doing visual workflows, because it's kind of easy to get lost in them sometimes. I mean, there's a time and a place for visual workflows, and I think they can be a great rapid development tool, but I wouldn't necessarily advocate, making like 300 steps inside a Logic Apps, but feasibly you could. I've seen people do crazier things. Let's go ahead and refresh. Let's see what happened to this JSON here. It's the schema. Oh yeah, that's right. So hold on. I'm gonna cheat a little bit here. We're gonna go back over here. I'm going to grab. This is gonna be a fun little iterative process here. We're going to go ahead and grab the Cosmos DB test, Logic app. And we're going to see and make sure that the schema is the correct schema as we'd expect it to be. Because, yeah, I thought that was, let's go back over here. Grab that. Okay. And that schema is as it was expected to be. Hold on. Okay, right. So there's a lot of little gotchas when using Logic Apps. The problem with super powerful tools is that you have to learn them pretty well, and there are things that you forget along the way. So the way that Twilio, lessons learned, the way that Twilio sends webhook data is as in a very specific format. It is, I think it actually told us before, but it sends it as a form URL encoded. So you have to use what's called a Logic App expression, trigger form data value, to actually retrieve the data out of that response. And so it's kind of it's a little bit of a gotcha there, but we can support that as a concept. So I'm going to go ahead and just grab that one, go back over here. I'm going to go ahead and get rid of this. And what's nice is that we don't actually have to parse the data. We can just go back over to Twilio, get message, unique SID is what we're going to be grabbing from the HTTP request. And what we're going to do is we're going to just grab that trigger form data value. So the name is somewhat self-explanatory, but it's pulling the data from the trigger, and the actual value that it's pulling is assigned to that key, the SMS SID. So grab that, save. Let's go ahead and hit it one more time, make sure this works. Back over here, refresh. Yay, our first succeeded of the evening. Not a bad thing. So now we have the message. So I just sent, the message text that I sent was just works, because I'm not very creative. And we can see that we actually have the data coming out of that Twilio message now. So let's actually do something with it. Let me go back over here to edit, flip over. Okay, so we have the message. I think now, I'm cheating. Yep. Okay. It's time to put it. It's time to put it into the. Well, actually, no. First, we're going to query. So we're going to query Cosmos DB. But before we query Cosmos DB, we actually need to go set up Cosmos DB collection. I'm going to keep on doing this just so I understand what level of kind of familiarity people have. How many people here use Cosmos DB currently? Okay, a few of you. Okay, cool. How many of you are familiar with NoSQL databases generally? Okay. Okay, cool. Or JSON-based databases. I mean, different behind the scenes. But okay, great. So Cosmos DB, like I said before, is just a way to kind of rapidly insert, change, modify data, all those kinds of good stuff, without having to have a model and migrating data, back and forth. So let's go ahead and go into here. This is the Cosmos DB kind of interface. I've already created an account inside Cosmos DB because that takes around 5 or 7 minutes to kind of provision. So what we're going to do is we're going to add a collection. And we're going to call it users. Whoa, not in all caps. Users. And we're going to call the container, or I'm sorry, we're calling this microstarter because we don't have a database yet. And we're going to call this users. And then we're going to create a partition key, which is, I'm not going to do it justice if anybody in here actually uses Cosmos DB and can explain this in detail, but it effectively helps Cosmos DB know where things are segmented in, where things are partitioned. So I'm going to go ahead and create this. And you can see now we have our Cosmos DB database. Items are where things get plopped into. There's nothing in there right now, but there will be shortly. So let's go back over to Logic Apps. Not that one, not the cheater Logic app. And so the first thing we're actually going to do is, it's going to be a little unintuitive because we're kind of working backwards here, but we need to step through the logic and actually assess, what's the next thing after a text message comes in. Well, the next thing is actually checking whether or not a user exists within our database that we're creating, because everybody's going to get registered and feasibly would be assigned some sort of a value. Let's say it's like tokens. We're not going to do that specific thing, but there might be a monetary value that you have in your account when you're funding something. So we're going to go ahead and do query documents. So this is all built into Logic Apps as I'm showing you. So the Cosmos DB connector is really nice. Microstarter, we're going to go over to oh, that's not the one I want. Hold on, I'm going to change up my connection. That's my old one. Let's add a new connection here. This one's going to be called Skyler Hartle. Create. Perfect. Microstarter, yeah, that looks great. Users, great. So we're not too far ahead now at this point. And so we have to add a new parameter, which is going to be a query. And the way that we're going to set this up is we are going to query by a specific ID. So let me grab, I'm going to cheat a little bit again here because I didn't want to remember this exact very simple SQL query. Provide the SQL query in there, and all this is saying is, select all items from the user's collection, and then specifying a variable u, where u.users equals in this case, it's going to be u.users equals where is it? The message from number. So essentially what we're going to do inside the Cosmos DB database is we're going to assign the message from number, meaning like the person who's texting, as the user ID, just as a simple way. Once again, this is rapid development, so this is not, if you have better approaches in order to take things to scale, definitely, but the goal here is to get to something as fast as possible. So we're going to grab that number and check to see if that exists. I believe this has to be in quotes. Not 100% sure. We'll find out in a second. We're going to go ahead and save that. That is saved. Now we can do a quick sanity check here. Go ahead and refresh. Go ahead and see where it failed. So you can see, well, actually, let's see, the collection cannot be accessed to the SDK version as create the new SDK version. Well, that's never a good sign when you see messages like that coming back from your connector library. We're going to figure out what that means in a second. Let's focus on the positives here. You can see that in the query here, the from number, the actual my phone number, just FYI. It was injected there into that query, which is great. Let's go ahead and hit this again and see what happens. In the interest of time, we might flip over to the one that I've already created, if this ends up not working out in our favor. But it's always worth trying to see if this thing will actually do what you want it to do. Collection cannot be accessed. Yeah, I'm not going to spend, so there's this thing in the startup world that's called pivoting, right? And so, fail fast approach here. So I'm going to go ahead and I'm going to flip over to the one that I created over the course of the weekend. I learned Cosmos DB, Azure Functions, all the services you're going to see here just in the past 3 days. So while it is kind of cheating and I won't be creating it fully under the 1 hour as I promised, I apologize. At the very least, you'll get to see kind of the approach that I was taking and how these tools can be used in combination. So I'm going to go ahead and do that because that'll be a much more impressive thing to kind of view. Although I did just break it before everybody came in here. So never mess with your production environment before a demo. So let's go ahead and I'm going to go ahead and just shorten everything down here and just kind of, I'm going to walk you guys through this. So we had our previous one that we saw before. We know what this HTTP request does. This is still assigned to the Twilio webhook. Get message does as we expected. Query documents, in this case, it was supposed to do as we were expecting it to do, but it did not. And then we actually have an Azure function in here. And so I'm going to go ahead. This is called check for users, and this is being called from Logic Apps. You can call an Azure function directly, and you can pass in data that came from the Logic app. For instance, we could pass in data from get message. We could pass in query data from Cosmos DB, all that kind of stuff. It's really powerful from that perspective. So I'm going to go ahead and flip over to what this one looks like, not that one. It's a really simple little Azure function. If you're at all familiar with JavaScript, this will look okay to you. If you're not, you're going to think, what the hell is going on? But generally speaking, what this little bit of logic is doing is it's just, I'll actually go back over to here and show you. Let me check. This one passes in the documents. Yes, perfect. So the documents object from that query call to Cosmos DB is being passed into this function. I'm checking the length on it, basically as just a quick check to kind of figure out, hey, was any data actually returned back from Cosmos DB? And if it wasn't, I'm going to respond with a status code of 200. That's simply just to keep on executing down the flow because it wasn't a critical error. It was actually expected behavior. And I'm going to assign this thing that says body, not found, meaning that nothing was found. Otherwise, if the array that contained all of that data was longer than 0, then it would just say, oh, we found somebody. That probably means that somebody exists within the database already. So just a quick and dirty. And the reason why I actually am advocating for a Azure Functions approach as opposed to doing it visually is when you have these kinds of checking, when you have these checks or you have parsing or you have these kind of longer form things that might need to scale out in the future, I would advocate moving over to Azure Functions and performing all that logic there because it does get cumbersome, like I said before, in Logic Apps. And this is really the kind of, when I talk about orchestration, I talk about using the best bits. This is kind of one of the places I see Azure Functions and Logic Apps working really well kind of in symbiosis together. So let's go ahead and go back over here. So this looks like a simple Logic app. It checks for the user, it returns back either not found or found. Let's go ahead and open up our next step here. So basically, as I said before, the body is going to return either found or not found. This is a step in Logic App. It's a conditional. It's basically an if-else. I supply the body from the Azure function, and I say is equal to not found. So if it's equal to not found, then it will run this branch of the application. So let's go ahead and kind of walk through what that would look like. So you know what? I'm going to do something kind of fun for us here. To make sure there's nothing, I'm going to flip back over to the other Cosmos DB instance I already had created. I'm going to go down to Data Explorer, and I'm going to show you guys what this looks like actually in real time as I punch data into there. I believe that's me right here. Yeah, okay. So actually, I think that this should work if, let me do this. So why don't we try this out? 425, 494, 414. So if somebody wants to text that number, or multiple people would like to text this number, we can see this data being auto-populated in real time into the Cosmos DB database, which would probably make for a more kind of compelling example of how fast and how quickly this can aggregate. Logic Apps, by default, they are asynchronous, meaning that requests will be processed as they come in. That can have some problematic behavior in terms of race conditions, but you can also make it synchronous if you want to. So we're going to see if any kind people punch through any data here yet. Otherwise, I'm going to have to. So let's go ahead and start with me. Oh, sorry. There you go. Hold on. This is good. See, it's collaboration. Thank you. Much appreciated. All right, let's go ahead and hit that thing again and see what we get. Okay, good. So that one came through on mine. Let's go ahead and, oh, hello. Cool. So we punched a bunch of data into here. You can see it's just coming through in more or less in real time. That's fantastic. Let's go ahead and move back over here to the Logic app and see what that actually looked like as it executed. You can see that these things were actually punched in. One of them failed. Let's see why this one failed. Oh, interesting. Okay, failed on the text message step. Okay, perfect. So basically, these things got punched in pretty fast. I imagine that more data, if I had to guess, is probably coming through. It looks like a few more failed. I wonder if maybe a rate limit is happening, maybe with the Twilio API, or something is happening somewhere. But I'm not going to dig too far into that because I don't think I need to fail more than I already have currently during this process. So let's go ahead and step back into the Logic app, and I can keep walking you through this. Perfect. So everything that you just saw, you should have all received a text message that said something goofy in it, I imagine, because it got sent back to you. If you didn't, that's probably because the Twilio API rate limited me. But none of you were in the system yet. And so it went to the true branch because you didn't exist. In this compose card here, which is a really common kind of construct that we use with visual workflow, is I'm actually creating a little JSON object. It's not, it doesn't do indentation yet, but that would be a nice feature. So feel free to put in a feature request, and you can mention my name in it. I'm sure the team would appreciate that. And so I assigned the ID. I created GUID because ID is required inside Cosmos DB. I assigned it some sort of tokens, which we're not going to get to at this point, but that you guys were going to spend that. And then I use the message from number from Twilio all the way back at the top as an ID for the. You have to supply it for the partition key essentially. So it's how you it's a way to associate the data-ish. From there, I actually punched that into Cosmos DB with this create or update document action. This output came from the compose card, and the partition value came from the message from the message from number, and then the text message was ultimately sent just to kind of confirm that. Okay, So this is the one that I broke, and so we're going to see if it works. Let's find out. I'm going to do a quick test here, and we're going to find out whether or not this is broken. Looks like it's good. Okay, so excellent. Well, let's check. Is there a timestamp on this? Well, hopefully that wasn't just a redundant thing. So I'm going to go ahead and walk you through kind of how this one works. This is going to get a little painful. Basically, if a user is found, we're going to move over to the false branch. And in the false branch, we're actually not using an Azure function in this case. So I'm just going to go ahead and nuke this one. We're going to use a series of things in Logic Apps called expressions, as well as a combination of compose cards and parsing some JSON. So what happens is that, let me click into this. I can show you. Hopefully you guys see that. Let me bring this up over here. Okay. So what happened here is that I'm using an expression to essentially take in one of the variables from that get message SMS and SMS action, and I am actually splitting it on the body, because the body key that comes from Twilio is the text message. And so I've created a pseudo, tokenized system of basically running commands based on the inputs that are provided from the body of the Twilio request. So you can imagine, I'll write something out here for you guys. Like if you write create, let's call it cats on the moon, and then you can set your fundraising goal. So this command here, if you actually text this to the phone number with whatever, this is the command, because we're creating basically a chatbot. This is the name of the campaign, and then this is the how much you want to fundraise. If you text that, this will get punched into the Cosmos DB database, and I'll show you what that flow actually looks like. So I'm going to pull this back up if anybody wants to actually give this a go. Otherwise, I'll kind of step through what that looks like. You know what I'll do is I'm going to make it even harder to see and go over here and slide that guy over. Okay. So let's go back to Cosmos DB and see what that actually looks like and see if any data was punched into the campaigns. Oh, perfect. I let free tacos for everyone. Let's see what your, here, let me make this a little bit bigger. Your campaign goal is 200, come back. Nope, hold on. Sorry, I used gestures. Here we go, free tacos for everyone. $250 for free tacos for everyone. I'm not sure that's gonna quite cut it. Cats on the moon, beer, Logic Apps, Cosmos Connector, dogs under the sea. $500. I'm not sure I'm going to be on board with that one as an initiative. Anyways, let's go back over to and see actually how these ran in reality. Let's look at one that succeeded. That's fine. Okay. So, stepping down all of this, we got the Twilio webhook was fired. We got the message. We queried to see if an account already existed. We checked to see that we sent the data from Cosmos DB into the Azure function. We checked to see if the account existed. The account did exist, hence why the body came back found. This evaluated to false, so we went into the false branch. We did not parse text message because we're not using that right now. However, we did split the text message. And as we remember, this came from the body of the Twilio request. So that text message that you sent in actually got split. And it got tokenized into 3 parts in an array: create, cats on the moon, and $500. We assigned it, we basically used a compose card to create a JSON object, and we assigned it to these various bits here. So campaign goal, campaign ID, and text action create. We parsed this JSON so we could have access to it later on in the Logic app. And then we have our switch case here. I'm going to go ahead and zoom out because this is where it gets even hairier. So in our switch statement, we're not going to look at that one because we didn't get to that. in our switch statements, we have these different cases. And I think that the cases are evaluated based on, let me look at the raw input really quick here. Yes. Once I get out of edit mode, I can show you how the switch took in a body. But the switch case, it was evaluated on the text action, and then it went and did a specific case based on that action. In this case, create was passed in. We know that because that was the first token. Let's look at our compose. We can see that the data was dynamically passed in, and so our output is this data. And then we went to Cosmos DB, and we inserted it in there. So that one worked perfectly fine. Over here, this one did not get fulfilled, which makes sense. Back down here, I'm going to close that. And so let me go over a little bit of the methodology around this. You could put this in an Azure function. You could replace this and do a lot of your conditional logic and your switching and all that kind of stuff in there. That's a perfectly fine method if you want to do that when you're orchestrating between these things. I think Logic Apps provides good utility in terms of orchestration. From a visibility perspective, I'm not sure with the switch statement. This was my first time kind of messing around to see how it would embed in there nicely. But the interesting thing is that you can at a glance really tell what the functionality of your application is, which I think is kind of fascinating because you get this snapshot that's really meaningful. And what's nice is that now I have these cases and I have this other logic built out. I'm just going to go ahead and keep on adding additional case statements to the cases to the switch statement, and I'll essentially be adding new features to this this text message fundraising kind of thing. And from a rapid development perspective, that's invaluable because then you can start punching out more and more and more. So I'm thinking whether or not there's, okay. So let me talk to you a little bit about how API management would sit on top of all of this. So I'll flip back over to here. I have another Logic app. It is called Retrieve Campaign Data. Let's go into here. It's really simple. It's a request response Logic app that all it does is it gets all of the data in the users collection in Cosmos DB and it returns it as a response. This was, I mean, really trivial to create. I mean, you could pull something like this down like in 5 seconds, and you could probably do something analogous in code, especially with maybe a Cosmos DB library and whatnot. And so it is a preference thing, but I actually happen to like the quickness in being able to request data and then integrate with other data sources from a Cosmos DB, which is why I did it in here. Anyways, back to my API management point. Right now, this is not. This is just a URL that's just sitting out here, and it can be accessed via post. If you want to secure this URL, you'd put API management on top of it, and then and essentially create a facade or a reverse proxy that would wrap this, and you could put authentication on there because right now this function has carte blanche to essentially pull all of the user data out of the collection, which is not good, not good practice in the least. So API management was on top of that. Similarly, if there was other Logic apps that you were using that needed to be kind of orchestrated together, API management could also sit on top of that. You just have to create them as HTTP requests, and you can orchestrate all of that. Also, functions can do a similar thing when creating microservices. So there's also that possibility too. I think that at this point, I'm going to flip back over to my other Logic app, Cosmos DB test, and I'm going to go over to edit here. I'm just going to have this up. But I mean that when I'm in kind of like summation about this in terms of the speed of development and why you would use this versus code and something like that, it really has to do, like I said before, with this push to more and more services being offered as these kind of prefabricated pieces, and that's why I talk about leveraging composition over these kinds of other patterns, is because although I did have to spend more time creating this than an hour, I was not able to create this in under an hour right now. I didn't have to learn the Twilio API. I very easily used Cosmos DB. I could integrate with a host of other Azure services. Actually, one thing I was toying around with was using the Azure bot service to actually create a better text interface instead of just doing this kind of token approach. And that would be really easy to integrate into this tool already, especially because we have a lot of these connectors to different Azure services. But ultimately, it's about what makes your life easier as developers and as people who want to create applications. I'm an advocate of all of these services, and I use all of them equally. It just depends on the scenario. So with that said, there is 5 minutes left in the session. I'm happy to answer any questions or anything like that, but otherwise, thank you for coming to this, and thank you for putting up with me as we walked through all these various bits.